There's a very specific feeling every human has experienced at least once. It's not the gentle regret of missing an opportunity years ago. It's the immediate crushing kind. The kind that hits you the exact second after you say something you shouldn't have. Maybe you're in your boss's office or sitting at dinner with your partner's parents. You open your mouth, say the wrong thing, and instantly you see their faces change. The air drains out of the room, and inside your head, a single thought screams louder than anything else. I need a reset button. In that moment, your brain tries to do something impossible. You want to grab the words midair and shove them back into your mouth. You want to rewind time. If you could just go back 5 minutes, just 5, you'd fix everything. You'd stay quiet. You'd smile politely. You'd eat your potatoes and keep your life intact. So let's try a thought experiment. Imagine you're not only someone with a talent for saying the wrong thing, but also a brilliant garage inventor. You rush home, ignore the emotional fallout, and head straight to your workshop. Sparks fly, metal bends. You weld, solder, and assemble something extraordinary. Maybe it looks like an old refrigerator wrapped in copper coils, but beneath the clumsy exterior lies a masterpiece, a working time machine. You climb inside. The air smells faintly of ozone and hot wiring. You don't want to visit ancient history or change world events. You have a simple goal. You just want to go back 10 minutes. That's it. You set the dial, press the big red button, and the machine hums as if the universe itself is shifting around you. The lights flicker, the vibration stops, and the timer now reads -10 minutes. You did it. You solved time travel. You reach for the door, expecting to step back into your kitchen, ready to undo your mistake before it even happens. But when you open the door, everything goes wrong instantly. The air is ripped from your lungs. There's no sound because there's no atmosphere to carry it. The moisture in your mouth begins to boil. Your eyes feel like they're swelling outward. You're not in your house. You're not even on Earth. You're floating in pitch-black emptiness, suspended in vacuum, freezing and burning at once. Somewhere in the distance, you see it, a tiny glowing blue sphere drifting away at terrifying speed. It's Earth, and it's leaving you behind. So what happened? Did your machine malfunction? Did you miscalculate the timing? No. Your time math was flawless. You did go back 10 minutes, but you made a mistake that almost every time travel story ignores. You forgot about space. We instinctively think of the ground beneath our feet as fixed. We treat Earth like a stage, solid, unmoving, permanent. We build houses, roads, and cities, assuming this location is stable. But nature doesn't recognize your street address. The universe is in constant motion. Start with Earth's rotation. Near the equator, the planet spins at roughly 1,000 miles per hour. In 10 minutes alone, the surface has shifted about 160 miles. If you remained in the same position in space, you'd already be far from where you started. But that's just the beginning. Because Earth isn't only spinning, it's also racing through space. Our planet orbits the sun at about 67,000 miles per hour. That's nearly 19 miles every second. In the 10 minutes you spent traveling backward in time, Earth would have moved roughly 11,000 miles along its path around the sun. So even if you somehow ignored the planet's rotation, you'd still reappear thousands of miles from where you intended, deep in the emptiness of space. And it doesn't stop there. The sun itself isn't sitting still. It's hauling the entire solar system around the center of the Milky Way galaxy at nearly 500,000 miles per hour. Over those same 10 minutes, our solar system would have traveled about 80,000 miles across the galaxy. Add it all together. The spin of Earth, the orbit around the sun, the motion of the sun itself, and the place you thought was here has shifted unimaginably far away. You stepped back in time, but you didn't follow the planet. You stayed put in space while everything else kept moving. The result is exactly what you experienced. You opened the door into the void, watching Earth shrink into a distant dot. This is the hidden tragedy of time travel. Moving through time alone isn't enough. Without perfectly matching the motion of the universe, you wouldn't just miss your destination. You'd die before you even understood what happened. Now you might be thinking, fine, That's just a navigation issue. I'm an engineer. I can solve trajectories. I'll calculate where Earth was 10 minutes ago and program my machine to go there. It sounds reasonable, like leading a moving target. Hunters aim ahead of a duck in flight. You'd simply aim behind Earth's current position. Problem solved, right? Not quite. Because to calculate that position, you need a reference frame. You need a map. You need coordinates. And here's where physics becomes truly strange. Coordinates relative to what? Imagine you're on a boat in the middle of a foggy ocean. You can't see land. The water moves, the clouds drift, the wind shifts. Without a fixed point, a lighthouse, a star, something stable, you can't define where you are. You need an anchor to measure against. For centuries, scientists believed such an anchor existed. Isaac Newton himself imagined something called absolute space, a hidden, rigid grid underlying the universe. Even if all matter disappeared, this invisible framework would remain, providing fixed coordinates. If Newton were right, you could locate Earth's past position on that cosmic grid and guide your machine perfectly. But as we studied light, electricity, and motion more carefully, we discovered something unsettling. There is no master grid. There is no universal stage. Everything in the universe moves relative to everything else. You move relative to the chair you're sitting on. The chair moves with Earth. Earth moves around the sun moves through the galaxy moves relative to other galaxies. There's no center, no absolute reference point, no fixed zero. Think of a ball rolling across a table on a moving train. To you on the train, it travels 10 miles per hour. To someone standing beside the tracks, it moves at the speed of the train plus 10 miles per hour. Both descriptions are correct because motion only exists relative to the observer. The same logic applies to Earth's past location. Ask the sun where Earth was 10 minutes ago, and you'll get one answer. Ask the center of the galaxy, and you'll get another. Ask a passing photon, and you'll get yet another. There is no single coordinate you can target. The past doesn't have one universal address. So even if you built a computer the size of a planet to track every motion in the cosmos, you'd still face an impossible problem. Without a fixed reference frame, there's no definitive position to aim for. Time travel isn't just hard, it's fundamentally undefined. And that's only the spatial problem, because there's another barrier, one that's even deeper. And that's only the spatial problem, because there's another barrier, one that's even deeper. We need to talk about the speed limit of the universe. You've heard of it before, the speed of light, about 186,000 miles per second. It sounds like just another number in physics, but it isn't. It's not merely the speed at which light happens to travel. It's the maximum speed at which anything, energy, matter, or information, can move through the universe. It's the speed of causality itself. Why does that matter for time travel? Because according to Einstein's theory of relativity, moving backward in time would require surpassing that limit. You'd need to travel faster than light. And that's where reality refuses to cooperate. You might think the solution is simple. Build a stronger engine, burn more fuel, push harder. But nature has a clever defense. Energy and mass are interchangeable. That famous equation, E equals mc squared, tells us that when you add energy to something, you also add mass. At everyday speeds, like driving a car or flying in a plane, the extra mass is so tiny it doesn't matter. But as an object approaches the speed of light, the effect becomes dramatic. We've seen this in particle accelerators. Scientists push tiny particles, like electrons, to incredible speeds. As they approach light speed, adding more energy doesn't make them much faster. Instead, the particles grow heavier. They resist acceleration. If you tried to push something all the way to light speed, the math predicts its mass would become infinite. Not just extremely large, infinite. And to move an object with infinite mass, you'd need infinite energy. There isn't that much energy in the entire universe. Even if you converted every star, every black hole, every particle into pure fuel, it still wouldn't be enough to push a single atom to that speed. So the universe has a built-in safeguard. It's not a lock or a barrier you can break with better engineering. It's woven into the geometry of reality. The faster you try to go, the heavier you become, until motion itself becomes impossible. You're trapped within the present. But it gets even stranger, because even if you somehow solved the energy problem and survived the vacuum of space, you'd still face another obstacle: the nature of time itself. We tend to imagine time as a river flowing forward. The past is behind us, the future is ahead, and the present is a shared moment everyone experiences together. It feels obvious that now should be the same for everyone. If you clap your hands, surely that clap happens at the same time for someone on Mars or an observer in another galaxy. Einstein showed that this intuition is wrong. There is no universal now. Time doesn't slice the universe into a single shared moment. Instead, each observer has their own version of the present, depending on their motion. To visualize this, imagine the entire universe as a giant four-dimensional sausage, a block of space-time containing every event that ever occurred and every event yet to come. Your life is like a long thread running through that block. How do we define the present within that structure? In classical physics, we thought we could slice the sausage straight across. That slice would represent everything happening simultaneously. But relativity tells us the angle of the slice depends on your motion. If you're standing still relative to someone else, your slices match. But if you're moving at a different speed, your slice tilts. That means events in your present might belong to someone else's past or future. There isn't a single universal moment that everyone agrees on. So when you try to build a time machine, you're not just jumping to a moment. You're trying to land on a slice of space-time that may not even align with your new motion. You're trying to step into a version of the past that isn't geometrically accessible from your perspective. You're chasing something that may not exist as a single location at all. And when you step back and look at everything we've covered, the dream of fixing a simple mistake by traveling 10 minutes into the past starts to collapse under its own weight. To make that tiny correction, you would need to overcome the rotation of Earth, the orbit of the solar system, and the motion of our galaxy. You'd need to aim for coordinates that don't truly exist, generate energy beyond what the universe contains, and navigate a geometry of space-time that refuses to give you a stable definition of now. Instead of stepping back into your kitchen, you'd end up drifting in darkness, the planet you call home shrinking into a distant glow. At first glance, this sounds bleak. It feels like the universe is locking us into a one-way journey toward the future, preventing us from undoing our mistakes. But look at it from another angle, and it becomes something very different. Imagine what reality would be like if we could easily step backward in time. Cause and effect would break down. Every action could be undone. Decisions would lose their weight because nothing would be permanent. The universe would resemble a house built from shifting bricks, where the foundation constantly rewrites itself. Nothing would truly matter, because nothing would stay fixed long enough to matter. The impossibility of time travel protects coherence. It preserves the chain of cause leading to effect, ensuring that events have meaning. When you say something hurtful or make a poor choice, that moment becomes part of reality. You can't erase it, but you can respond to it. You can apologize, learn, and change. The forward flow of time gives actions consequences, and consequences give life structure. There's another perspective here too, one that's easy to overlook. Think about how fast we're actually moving right now. Earth spins, races around the sun, and together we sweep through the galaxy at astonishing speed. Yet you don't feel any of it. Your coffee cup rests calmly on the table. The air stays around you instead of being torn away. You feel still. That stability isn't an illusion. It's the result of gravity and inertia working together. Gravity curves space-time in such a way that it holds the atmosphere to the planet and holds you to the ground. In a sense, we're passengers on a spaceship equipped with perfect inertial dampeners. We're flying through a violent, high-speed universe inside a bubble of geometry that makes everything feel calm. That realization is far more astonishing than any fictional time machine. We don't need to visit the past to experience wonder. The fact that we can understand the physics of this motion at all is extraordinary. We are arrangements of atoms that somehow develop the ability to question the universe itself. And that brings us to a final reflection about mistakes, time, and what really matters. And that brings us to a final reflection about mistakes, time, and what really matters. The fantasy of a rewind button is powerful because it promises control. It suggests we could erase embarrassment, undo harm, or correct choices without consequence. But if you think about it carefully, that power would strip life of its meaning. The permanence of our actions is what gives them value. When you speak, act, or decide, those moments become part of the universe's history. They cannot be deleted. And because they remain, they shape who you become next. That may feel unforgiving, but it's also what makes growth possible. If every mistake could be undone, there would be no reason to learn. If every awkward conversation could vanish, we would never develop empathy or self-awareness. The forward direction of time forces us to confront our actions, repair what we can, and carry the lessons forward. In that sense, the arrow of time isn't a prison, it's a teacher. There's something else worth noticing here. Even though we cannot travel backward, we are never truly disconnected from the past. Every atom around you has a history stretching back to the birth of stars. The oxygen you breathe was forged in ancient supernovas. The atoms in your body were once scattered across cosmic clouds. The past isn't somewhere else. It's woven into everything that exists now. At the same time, the future isn't predetermined. While physics sets boundaries, like the speed of light or the geometry of space-time, it doesn't dictate your choices. Within those constraints, human decisions still matter. You can't go back and change what happened 10 minutes ago, but you can decide what happens in the next 10. That ability to move forward with intention is more powerful than any time machine. It's how relationships heal, how discoveries happen, how societies evolve. The impossibility of rewinding forces us to focus on what we can influence, the present moment and the path ahead. Consider how extraordinary that present moment actually is. You're standing on a planet racing through space at immense speed, held together by gravity, surrounded by a fragile layer of atmosphere that makes life possible. And inside your mind, electrical signals are forming thoughts that can reflect on the universe itself. That combination, motion, stability, awareness, is remarkable. We often imagine science as something distant or abstract, but in reality it's deeply personal. Understanding how the universe works changes how we see ourselves. It shows us that even our regrets are part of a larger story unfolding across space-time. They're not isolated failures. They're points along a path that keeps moving forward. So the next time you make a mistake, resist the urge to search for a rewind button. Instead, remember how much effort the universe invests just to keep you here, alive, breathing, and thinking. That realization shifts the question from, how do I undo this, to, what do I do next? And that leads to one final thought. The universe does not offer rewind buttons, but it gives us something better: continuity. Every moment flows into the next, carrying forward the results of what came before. That flow is what allows stories to exist, relationships to deepen, and knowledge to accumulate. Without it, life would be a scattered collection of disconnected fragments instead of a meaningful journey. Think about what it means that we can't go back. It means that apologies matter. It means that forgiveness matters. It means that learning matters. The impossibility of reversing time forces us to live with intention, to recognize that each action leaves a trace. That permanence may feel intimidating, but it's also what makes existence coherent. It ensures that our choices contribute to something larger than a single moment. There's a strange comfort in that idea. We often imagine the universe as cold or indifferent, yet its structure quietly protects the logic of our lives. The same physical laws that prevent us from undoing our past also preserve the stability that lets us build a future. They keep cause connected to effect, memory connected to experience, and identity connected to growth. And while we can't revisit yesterday, we can understand it. Science gives us that power. It reveals the patterns behind motion, energy, and time, allowing us to see how everything fits together. That understanding doesn't diminish wonder, it deepens it. Knowing that we're racing through space on a spinning world, held in place by curved space-time, makes the ordinary feel extraordinary. It also reminds us that the most meaningful journeys aren't through time, but through understanding. Every new discovery, every new perspective moves us forward in a way no machine ever could. We explore the universe not by jumping to different moments, but by expanding what we know about the one we're in. So when you find yourself wishing you could undo something, remember this: the universe doesn't run backward, but it always moves forward with you in it. Your next choice is still unwritten. Your next conversation can still be better. Your next step can still shape what comes after. Take a breath. Notice the ground holding you steady, the air you're borrowing from the atmosphere, the stars overhead marking distances beyond imagination. All of it is happening within a framework so intricate that we're only beginning to understand it. And yet, inside that vast system, your decisions still matter. The past is fixed, the future is open, and the present is where they meet. That's not a limitation. That's the space where life actually happens. So keep asking questions. Keep learning. Keep moving forward. The universe is a puzzle that rewards curiosity, and every step you take in understanding it brings you closer to appreciating how remarkable this moment really is. And maybe that's the real message of time travel. Not that we need to escape the present, but that the present is already the most extraordinary place we could possibly be.